Welcome to LDI 1.3. Before we get started into this LDI, let's review a fundamental definition. The definition of statistically significance, or statistical significance. The data collected are said to be statistically significant if they are very unlikely to be observed under the assumption that the null hypothesis is true. If the data are statistically significant, then our decision will be to reject the null hypotheses. So what does this all mean? Let's go over this real quick here, okay? So first key thing here about statistically significant is that the data collected, or the data, are very unlikely to be observed under the assumption that the null is true, okay? So what do we mean by that? Well, what we're going to do is this. We're going to say, okay, I'm going to go ahead and assume for a moment that the null hypothesis is true, that is exactly the way of the world. Then I'm going to go out and I'm going to collect some data. I take a look at that data, and if that data was highly improbable or highly unlikely to be observed under that assumption that the null was true, then the null must not be true. So what we'll do is reject that and accept in its place the alternate hypotheses, okay? So if the data is statistically significant, then what that really is equivalent to saying is reject the null hypotheses. Okay, so let's go take a look at the LDI with this information. So in LDI 1.3, we've got complaints about making chips. That shows up on page 10 of the text. Last month, a large supermarket chain received many customer complaints about the quantity of chips in 16-ounce bags of a particular brand of potato chips. Wanting to assure its customers they were getting their money's worth, the chain decided to test the following hypotheses concerning the true average weight in ounces of a bag of potato chips in the next shipment received from their supplier. The null is that the average weight is at least 16 ounces. In other words, you're getting your money's worth. So you're getting your 16 ounces in your bag of chips. The alternate, which is what the researchers believe based upon the complaints, is that the weight is what? It's less than the 16 ounces. So if there is evidence in favor of the alternate hypotheses, that is, we reject the null, the shipment will be refused and a complaint registered with the supplier. Some bags of chips were selected for the next shipment and the weight of each selected bag was measured. The researcher for the supermarket chain stated that the data were statistically significant. So we want to know three things. What hypothesis was rejected? Was a complaint registered with the supplier? Could there have been a mistake, and if so, describe it. Okay, so let's go ahead and see if we can answer these questions, okay? All right, so first of all, what hypothesis was rejected? Well, the data was statistically significant, so we rejected, right? Which one did we reject? The null, right? So if we rejected the null hypothesis, what that means is the data are statistically significant. If the data are statistically significant, we rejected the null hypothesis or the status quo. We're feeling that, in fact, that these bag of chips are weighing less than 16 ounces, okay? Was a complaint registered with the supplier? Well, the answer there, of course, is going to be yes, because we rejected the null hypothesis, and we could even throw in that the shipment was returned, because that was what the consequence was, right? If the complaint was registered, we're going to return our shipment, okay? All right, last but not least, and this is probably the most important question so far here, is could have there been a mistake, and if so, describe it. Now, many times students get a little confused with this question because they'll say, well, yeah, you know, the scale could have been broken, or the bozo could have eaten a few chips out of the bag before he measured it, or things like that. But, you know, that's really not what they're looking for here. We're going to assume that the researcher that they hired knew what they were doing and that all of the data collection procedures were done correctly. So what we could have had happen is we could have got a bad sample. In other words, a sample that is not representative of the actual population. And we're going to talk some more about how to sample correctly when we get into chapters 2 and 3. But for the moment, just to say we got a bad sample, it's just luck of the draw, okay? And we rejected HO, the null, when in fact it really was true. So in other words, we made a mistake here in saying that the null hypothesis was false when in fact it really was true, okay? And we're going to start talking about that here real quick. That's actually referred to as a type 1 error. And we're going to get into that here real quick, starting in the following LDIs. So hopefully that helps you out, and I'll see you all back here in LDI 1.4.